All right, we're doing balancing chemical equations with Lego, and this is the fourth type of chemical equation. This is a double replacement. Now, this one is naturally the most complex of all of the ones we've done. If we're writing it out in its simplest form, it's AB plus CD. Now, there's a couple of things that seem like they could work. We're not going to go into all of it here, but in our cases, the things that go first always stay first. So we're going to switch the places of the stuff that's second. So now it's going to be AD plus CB. That may seem a little bit confusing, but this is the basic format, all right? Now, the problem that we're going to work is number 20 on the problem set. That's going to be NaBr plus CaF2 goes to NaF plus CaBr2. Put all of our dashes in front of stuff so we can write our numbers. And then I like to go ahead and put that wall right down the middle. Everything on this side has to equal everything on that side. We will be counting atoms. Remember, if there's a 2 at the end of it, that means there's 2 atoms there. So we have 2 bromines on this side, we have 2 fluorines on this side. Next up, we're going to go ahead and list off all of the possible atoms that show up, and we're going to list on both sides. Now, a lot of times I go ahead and I write them in the same order on both sides just to make it easier to find things. So that's how I've got my list written. On your paper, if you want to go down, you can. I was trying to write it big enough that it's easy to see on the video. And again, pardon my penmanship, I know it's not very good. Now for step 1, we're going to go ahead and put a 1 in the blanks of our equation and see how things work out. So let's go ahead and count. We have 1 Na here, that's a sodium. We have 1 Br, that's a bromine. We have 1 Ca, that's a calcium. We have 2 fluorines, that's the F. Now, it's okay if you don't know what the names of these are right now. You can look at a periodic table, or if you have to memorize them for class, that's one way that you can get them. But as far as for writing it on the equations, it doesn't matter. Okay, over here we have the Na. So 1 Na here, that's sodium. 1 of the Fs, that's our fluorine. 1 calcium, and 2 of the bromine. Okay? Pardon my 2's and how yucky they look writing them upside down. As you can tell, our numbers do not all match. Our sodiums and our calciums do, but our bromines do not, and our fluorines do not. So this is where we bring the Legos in, so we can start to have a way to visualize it. So I'm going to go ahead and write down to label our colors to make this easier to keep track of. And we're going to get all the way up to 4 colors this time. All right, so red, blue, yellow, and green. So let's go ahead and see here. NaBr, we've got red and blue. Ca and F, that's green and yellow. And notice there's 2 fluorines, so that gives us 2 greens. All right, over here, our sodium and our fluorine, that will end up being red and green. And then we have our calcium and our bromine. Remember, there's 2 bromines. That gives us this. So here's looking at the Legos. As you can tell, it's very easy to see. Our greens don't match up. Our blues don't match up. Once we have that visualization, we can start playing around with it. So I'm going to set the Legos aside. And I'm going to go ahead and rewrite the chemical equation with blanks. As I say it, and I've taught this long enough, I know this step is the thing that students hate the most. They hate this more than actually substituting and trying the numbers in. They hate writing it down. So unless you are different, right now is probably where you're saying, but I don't want to do it that way. I would rather just mark things out or erase. You can do that. But just like in your math class, if you don't show your work, it's not always as easy to see where mistakes are. And so I highly recommend doing it this way. It's only paper. Those trees have already died for your education. So Go ahead and use that paper if you need to. It will be worth it in the long run. And trees grow like, well, they grow like plants. They're all over the place. We always have more. Okay, so if we just take a look at our Legos, it's easy to see we don't have enough greens. So we're going to need to double this. So let's go ahead and let's double it. Now, if we do that, our greens match up. Our yellows are matched up. We have one problem left. We don't have enough blues. So let's go ahead and do another one of those. Now we have the same number of reds, we have the same number of blues, we have the same number of greens, and we have the same number of yellows. Right now, this looks right. So let's go ahead and put those numbers in. So we've got 2 of those units, we've got 1 of these units, we've got 2 of those units, we've got 1 of those units. Again, pardon my upside down writing, it's not very good, I know. Now let's go ahead and start counting things out. Our sodiums, we have 2 sodiums, that matches up. We have bromines here. We have bromine times 2. So that's 2. Our calciums, we have 1. And the fluorines, we have 2. Over here, we have the sodiums, 2 of them. The fluorines, we have times 2. The calciums, we have times 1. The bromines is 2 times the 1. Now, let's check. 2 sodiums, 2 sodiums. 2 calciums. Or sorry, 1 calcium, 1 calcium. 2 bromines, 2 bromines, 2 fluorines, 2 fluorines. Look at that. Our Legos helped us out. We have the right answer here with the Legos. We have the right answer here. We have just completed 4 different types of balancing chemical equations. That is the 4 types. If you go back through these videos and review them and practice and do your problem sets, you're going to find some that are a little more complex, but they will still work. You always have the same amount on one side of the arrow as you have on the other side of the arrow. So keep at it. You'll do great. And thank you for watching.